Have you ever imagined sailing through space? Not with rockets, but on the gentle push of sunlight. It sounds like something straight out of science fiction, right? Well, what if I told you it's not science fiction at all? It's real, and it's happening right now. Today, we're rediving into the incredible world of solar sails, one of the most elegant and revolutionary technologies in space exploration. So, how exactly does a solar sail work? It's surprisingly simple, yet brilliantly clever. Imagine a huge, ultra-thin mirror-like sheet, often thinner than a human hair, stretched out in space. Now, think about light. We don't usually feel it, but light is made of particles called photons. When these photons hit the sail and bounce off, they transfer a tiny bit of their momentum. It is like a continuous stream of microscopic billiard balls hitting the sail and giving it a gentle, constant push. This push is incredibly small. If you held a solar sail in your hand on Earth, the force from the sunlight would be about the weight of a paperclip. You'd barely feel it, but in the vacuum of space, where there's no friction or air resistance, this tiny, constant push adds up. Over days, weeks, and months, a spacecraft with a solar sail can accelerate to incredible speeds, all without using a single drop of fuel. Think of it like this. A rocket is a sprinter. It gives a massive, powerful burst of energy for a short time, and then coasts. A solar sail is a marathon runner. It starts slow, but it just keeps going, getting faster and faster over time. This makes it perfect for long-distance journeys across the solar system and even beyond. The idea isn't new. Johannes Kepler first proposed it back in the 17th century after observing that comet tails always point away from the sun. He guessed that some force from the sun was pushing the dust and gas away. It took a few centuries for technology to catch up, but in the 20th century, science fiction writers like Arthur C. Clarke popularized the concept, dreaming of cosmic yacht races between the planets. But the real journey from fiction to fact began with NASA and other space agencies. One of the first major attempts was by the Planetary Society with Cosmos 1 in 2005. Unfortunately, a rocket failure meant the spacecraft never reached orbit. It was a heartbreaking setback, but the dream was far from over. The breakthrough moment came in 2010. Japan's space agency, JAXA, launched a mission called IKAROS, which stands for Interplanetary Kite Craft, accelerated by radiation of the sun. IKAROS successfully deployed a beautiful, square-shaped sail spanning 14 meters on each side. It was the first spacecraft to demonstrate that solar sailing in interplanetary space was not just possible, but practical. IKAROS flew past Venus, proving that we could navigate the solar system using nothing but sunlight. It was a monumental achievement. Following Japan's success, NASA got back in the game with its NanoSeldi project. This was a tiny CubeSat designed to test sail deployment in Earth's orbit. After a tense delay, the sail unfurled in 2011, becoming a bright, shining object that could even be seen from the ground. It successfully demonstrated how solar sails could be used to orbit satellites, helping to clean up space junk. But the most famous solar sail mission to date is probably the Planetary Society's LightSail 2. After the disappointment of Cosmos 1, they didn't give up. LightSail 2, funded by thousands of space enthusiasts around the world, launched in 2019. Its mission was simple: to show that a small satellite could raise its own orbit using only the power of sunlight, and it worked beautifully. For years, LightSail attacked in orbit, just like a sailboat on the ocean. By turning its sail relative to the sun, it could either speed up and raise its altitude or slow down. The mission was a resounding success, proving that controlled solar sailing was a viable technology for small, low-cost spacecraft. LightSail 2 far outlived its expected mission, continuing to sail the skies for over 3 years before re-entering the atmosphere. So, what's next for solar sails? The future is incredibly bright. One of the most exciting projects is NASA's Advanced Composite Solar Sail System, or AX-3. This mission is all about building bigger and better sails. The challenge with large sails is the long poles that support the sail material. Traditionally, they've been heavy and bulky. AX-3 is testing new booms made from lightweight composite materials that can be rolled up tightly for launch, and then unfurl to be much longer and more rigid than previous designs. This could allow us to build sails the size of a football field or even larger. Why go bigger? A bigger sail catches more sunlight, which means more push. This opens up a whole new class of missions. We could send probes to observe the sun's poles, a region that's very difficult to reach with conventional rockets. We could create a network of satellites to monitor space weather, giving us early warnings for solar storms that could disrupt our power grids and communications. Another incredible mission on the horizon is NASA's solar cruiser. This is a technology demonstration mission planned to fly a massive sail, about 1,600 square meters. That's roughly the size of 4 basketball courts. Solar Cruiser's goal is to travel about 1 million miles toward the sun to a stable observation point, demonstrating that large solar sails can enable ambitious missions to study our star and the solar system. And what about deep space? This is where solar sails truly shine. For missions to the outer planets or even other star systems, the amount of fuel required for a rocket-powered spacecraft is astronomical. Solar sails offer a way to travel vast distances without that heavy fuel tank. You get a continuous, free push from the sun. Projects like Breakthrough Starshot are taking this idea to its extreme. The plan is to use a powerful ground-based laser to push tiny wafer-thin probes with miniature solar sails, accelerating them to 20% the speed of light. At that speed, they could reach our nearest star system, Alpha Centauri, in just over 20 years. It's a concept that pushes the boundaries of engineering, but it shows the ultimate potential of light-powered travel. Of course, there are challenges. Solar sails need to be incredibly lightweight, but also strong enough to survive the harsh environment of space. Deploying a massive, flimsy sheet without it tearing or getting tangled is a huge engineering hurdle. And the further you get from the sun, the weaker the sunlight becomes. So the push gets smaller and smaller. That's why concepts like Breakthrough Starshot plan to use powerful lasers to provide that initial, massive acceleration. But the progress we've seen, from IKAROS to LightSail 2, and now with Ax-3 and Solar Cruiser, is just breathtaking. We've gone from a theoretical concept to a proven, flight-tested technology in just a couple of decades. Solar sails represent a more sustainable, long-term vision for space exploration. They free us from the limitations of carrying our own fuel, allowing for missions that are longer, more ambitious, and ultimately, more elegant. It's a future where we navigate the cosmos on beams of light, like ancient mariners, using the wind to explore the oceans. The age of solar sailing has truly begun, and the universe is the ocean waiting for us to explore. Thanks for watching. If you've found this journey into the future of space travel as fascinating as I did, do you and T forget to hit that like button and subscribe for more deep dives into the incredible science and technology shaping our world. Let me know in the comments what you think the first major destination for a large solar sail should be. Until next time, keep looking up.